Okay, this table starts with, this question starts with a table of data, and I've got to estimate the mean and standard deviation of the weekly earnings. So it's saying estimates, because what I'm going to be doing is I'm going to be finding an X bar, and I'm going to be finding, standard deviation is SX. Be really careful between standard deviation and variance. This is standard deviation. So X bar and SX you're going to get from your calculator, and then you're going to use X bar as an estimate of mu and SX as an estimate of sigma. Okay, now the data, you're going to need mid-values. So for the first category, we need to think what this goes up to. Now, the wages are actually to the nearest pound, so that's a bit sneaky. This category doesn't go all the way up to 110. It's actually the highest value that could be in this category is 109. So I need to do 100 plus 109 divided by 2 to get the mid-value. So that same thing applies here, here, and here. Fill in the actual upper limit of the boundary before working out the mid-value. And here we're just going to do 175 plus 204 divided by 2 for the mid-value. So there's quite a bit to do for these 2 marks. Okay, then part B. We're now we've got 2 options, a 5% pay increase or a 3% pay increase plus a fixed lump sum of £3, okay, per week. So we've got to find the new mean and standard deviation. So this is scaling, okay. What we're doing here, for a 5% pay increase, we're going to multiply all the wages by something. So for a 5% increase, you multiply by 1 point something, and that will affect, well, you need to think about whether multiplication affects the mean and whether it affects the standard deviation, okay. And for this one here, we've got a 3% pay increase, so we're multiplying by 1 point something again, okay, but we are also adding on £3, so you need to think about which of multiplication and addition affect the mean and which affect the standard deviation, and you need to apply those to your original values of X bar and SX. So your answers, you can have 2 answers for this, a new mean and a standard deviation, and 2 answers for this, another new mean and another new standard deviation.